Twisted, making code non-blocking. I'm a bit puzzled about how to write asynchronous code in Python/Twisted. Suppose, for argument's sake, I'm exposing a function to the world that will take a number and return true/false if it is prime/non-prime. So it looks vaguely like this. Just to illustrate, now let's say there is a web server which needs to call a sprime based on a submitted value. This will take a long time for large num_array. If in the meantime another user asks for the primality of a small number, is there a way to run the two function calls asynchronously using the reactor/deferreds architecture so that the result of the short calc gets returned before the result of the long calc? I understand how to do this if the asprime functionality came from some other web server to which my web server would do a deferred get page. But what if it's just a local function? I.e., can Twisted somehow timeshare between the two calls to asprime, or would that require an explicit invocation of a new thread? Or would the asprime loop need to be chunked into a series of smaller loops so that control can be passed back to the reactor rapidly? Or something else?
I think your current understanding is basically correct. Twisted is just a Python library, and the Python code you write to use it executes normally as you would expect Python code to. If you have only a single thread and a single process, then only one thing happens at a time. Almost no APIs provided by Twisted create new threads or processes, so in the normal course of things your code runs sequentially. Asprime cannot execute a second time until after it has finished executing the first time. Still, considering just a single thread and a single process, all of the concurrency or parallelism of Twisted comes from the fact that instead of doing blocking network I/O and certain other blocking operations, Twisted provides tools for performing the operation in a non-blocking way. This lets your program continue on to perform other work when it might otherwise have been stuck doing nothing waiting for a blocking I/O operation, such as reading from or writing to a socket, to complete. It is possible to make things asynchronous by splitting them into small chunks and letting event handlers run in between these chunks. This is sometimes a useful approach if the transformation doesn't make the code too much more difficult to understand and maintain. Twisted provides a helper for scheduling these chunks of work, Cooperate. It is beneficial to use this helper since it can make scheduling decisions based on all of the different sources of work and ensure that there is time left over to service event sources without significant additional latency. In other words, the more jobs you add to it, the less time each job will get, so that the reactor can keep doing its job. Twisted does also provide several APIs for dealing with threads and processes. These can be useful if it is not obvious how to break a job into chunks. You can use defer_to_thread to run a thread-safe function in a thread pool. Conveniently, this API returns a deferred which will eventually fire with the return value of the function, or with a failure if the function raises an exception. These deferreds look like any other, and as far as the code using them is concerned, it could just as well come back from a call like getPage, a function that uses no extra threads, just non-blocking I/O and event handlers. Since Python isn't ideally suited for running multiple CPU-bound threads in a single process, Twisted also provides a non-blocking API for launching and communicating with child processes. You can offload calculations to such processes to take advantage of additional CPUs or cores without worrying about the GILs slowing you down, something that neither the chunking strategy nor the threading approach offers. The lowest level API for dealing with such processes is reactor.spawnProcess. There is also Ampool, a package which will manage a process pool for you and provides an analog to defer_to_thread for processes, defer_to_amprocess.
First of all, organize our sign.